The topic of the today's video lecture is ultrasonication for the synthesis of nanoparticle. Actually, it is a video lecture in a series of video lectures where I have explained different methods for the nanoparticle synthesis, including that of the hydrothermal method, including that of the Solgen method, the co-precipitation method and other methods also. So the topic of the today's video is all about ultrasonication. So as the name indicates, actually the ultrasonication is a type of the synthesis of nanoparticle in which the ultrasound waves will be used. Okay, so ultrasound has become an important tool for the synthesis of nanoparticle. Okay, besides the hydrothermal method and other methods, ultrasound is also being in use for the preparation of the nanoparticle. So what happens basically when the liquids are irradiated with ultrasonic irradiation? Ultrasonic cavitation will form. So how does this take place? We have a beaker here. This beaker contains the solvent and solvent has the precursors. Okay, so these dotted particles that you can see are actually the precursors. Okay, so this is the probe and probe serves as a medium through which ultrasound waves are transferred to this solvent. Okay, in the start of this reaction, in the start of this procedure, all of the precursor molecules are are in a place, okay, are just congested and there is very much little space between them. So when the ultrasonication occurs, when the ultrasound waves are passed through this probe into this solvent, what happens? These particles are uniformly dispersed in the whole medium. Okay, when they are uniformly dispersed in the whole medium, there is the formation of the ultrasonic cavitation. And what happens when there is a space, then what happens? The reaction occurs. Okay, where we have two different precursors. Okay, when we have two different precursors, we provided the ultrasound. The ultrasound created what? The ultrasound created the ultrasonic cavitation, and then we have the spaces, and then the molecule gets energy through the ultrasound. When the molecule gets energy through the ultrasound, then these molecules, they will react with each other and they will form the product. So when the precursors are present in this solvent and this solvent is aggravated by the ultrasound wave, what happens? This aggregated precursor molecule will first of all become dispersed, they will gain the energy and then they will react with each other and will form the product. Okay, so ultrasonic cavitation produces a variety of physical and chemical effect. Okay, so what happens when we provide the ultrasound waves? There will be some physical and the chemical effects such as the high temperature, the high pressure and cooling rate. Oh, and these conditions, that is the high pressure, the high temperature and high cooling rate, they provide a unique environment for the chemical reaction under the extreme conditions. Okay, so through this the final nanoparticles are formed. So ultrasound is a fine method for the preparation of nanoparticles with controllable morphologies. Okay, so this is one of the important point, that the ultrasound, through ultrasound, the particles that are formed, we can control their morphologies. Okay, so the next thing is, as you can see here, that before sonication we have this ultrasonic probe and all of these precursors are dispersed, are aggregated. Okay, so there is an aggregation, as you can see there, that there 3 to 6 molecules are aggregated in a place, and again here the molecules are aggregated in the place, and after the sonication what happens? All of these molecules are dispersed in the medium. They have gained energy, they can react with each other and they will finally form the product. Okay, so what are the advantages for the nanoparticle synthesis by this ultrasonication method? Actually, nanoparticles synthesized at ambient temperature. Okay, you do not have to provide a high temperature. These nanoparticles can be synthesized at an ambient temperature, and the reaction rate achieved using ultrasound is quite high. Okay, actually the reaction rate in this method is very high. It is not very much time taking process, usually 3 or 4 or 5 hour, and the product is formed in such a small time. Okay, so less time is required to produce nanoparticle. It is a quick and simple method. Okay, also it means if the reaction time is less, so it's a quick method, and it's also a simple method. You just have to provide the ultrasound waves to the precursor, and then the product will be formed. So various shapes and assemblies of nanoparticle may be synthesized. So we have various shapes, for example nano rings, the nanobelts, and the core shell structure and cluster structure of the bimetallic nanoparticle. All of these structures can be formed by this ultrasonication method. Okay, so beside having many advantages, there are also some disadvantages to this. Well, the heat sensitive material cannot withstand the acoustic cavitation. Actually, what happens when the ultrasound waves are provided in the solvent, so these ultrasound waves will increase the kinetic energy of the molecule, and increasing the kinetic energy will increase the temperature. So those materials that are heat sensitive, they cannot withstand this kind of high energy. So this is one of the disadvantages, that heat sensitive material cannot form nanoparticles through this method. It is an energy intensive process. Actually, as you can see here, that we are providing the ultrasound, and ultrasound requires energy, so it is an energy intensive process, and scale up is difficult. Actually, it is a laboratory technique, so scaling up, so actually producing more product is difficult in this case. Although it is a method which yields nanoparticle at ambient temperature condition, the energy supply needed to carry out sonochemical synthesis is quite high. Okay, so the energy required is quite high, and therefore the yield per unit energy supplied is very low. So one of the main drawback is the lack of homogeneity. Okay, so how is the lack of homogeneity a drawback? So as you can see here, that this is the probe that is providing the ultrasound wave. So ultrasound waves are stronger near the probe, and they becomes weaker as we move away from the probe. So at the sides of the beaker, the effect of the ultrasound is very much less as compared to the part where the probe is present. So the ultrasonic waves are strongest near the probe, and they are weakest farthest away from the probe. So one of the main drawbacks of the is the lack of homogeneity. So this creates a lack of homogeneity even using the ultrasonic probe, which fortunately is easily controlled. Okay, ultrasonic probe is easily controlled, but depending on the intensity of sonication and the position of the probe in the sample bath, the efficiency changes as the energy of ultrasound varies. Okay, so depending on the intensity of sonication and depending on the position of the probe, there is a little bit of lack of homogeneity in this process. Rest of it all is fine. You can prepare your nanoparticles through this method. Okay, that was all for today's video lecture. So if you have any question, you can ask me in the comments. Thank you and Allah Hafiz, and do not forget to like the video and subscribe the channel, and finally follow me on Instagram too. Thank you.